I'm Shane Phillips, the Chief Water Operator with the District of Lillooet. Just want to talk a little bit about our treatment process through stage one of our water treatment. We bring our water in through two wells that are situated here on the banks of Cayuse Creek. We then pump the water from the wells to our treatment facility. So come along and we'll check it out at the treatment facility. Okay, we'll start the process. In order for the wells to release any water into the treatment facility, we have a few instruments that tell the quality of the water before it gets to the building. So we can determine whether it is a proper product to treat and for our sterilization disinfection. This is a UVT meter, an ultraviolet transmittance recorder, and it tells how the UV lights will work on the water. So what intensity the lights need to be for the sterilization process. If this ever records lower than a 70% transmittance, it will not allow water to come into the facility because our UV reactor will not handle anything that is that turbid, basically. And then it goes through an inline turbidity meter, which tells sediment and particulate. Goes into my chlorine meters and my pH meter. And the pH is a very important part. It also is a gauge for the quality of the product. The more neutral the pH, the better sterilization disinfection quality you can achieve. I have everything here in line, so it's right in your face. You can see all of your numbers, your totals on residuals for the sodium hypochlorite that we add, which is basically 1% bleach solution. But it is sodium hypochlorite. It's just a different name for bleach. After it goes through this process, I check alarms and the functioning of all the equipment through the computer process. Let's check that out. Okay, after I've checked all my instrumentation, I make my way to the computer area and check the status of all of my equipment, my well levels, make sure that all of my system settings are correct before we start the day of distribution. Check all of my turbidities, my chlorine levels, my pH, and my temperature, just to ensure that there was no issues in the evening. Check my alarms. Once we confirm that everything is running smoothly, then we continue on with the rest of the process. Okay, and after I've checked to make sure the status of all the equipment is in the good, we come out and I check all of my equipment. This is my ultraviolet reactor, and what it does is it sterilizes all organisms and makes them so they can't reproduce in your body. I make sure that all of the another piece of instrumentation which helps me in knowing the condition of my UV reactor. Okay, the next step is once the UVT meter that I showed you in the lab, once that has confirmed that the water is of good treatment quality, it sends a signal through the PLC, which sends a signal to the UV reactor telling it that it is now safe for it to warm up. And it has a 2-minute warm-up cycle where it will warm up the lights so it's not hard on the equipment, and then it will open the wells and allow the water to come in through the ultraviolet lights, which are right in this sleeve. They're contained because it is The ultraviolet light kills the organisms in the water with radiation. After that process, then we add some sodium hypochlorite, and this is our injection point. So after it goes through and gets treated through sterilized through the UV, it travels through, gets chlorinated, and that is another defense, a safety precaution, because the UV will sterilize the microorganisms, whereas the chlorine in the proper dosage will kill the bacteria. Okay, now I'll show you the hypochlorite room, where we are lucky in Lillooet. We actually have a sodium hypochlorite generator system where I can turn a salt brine into sodium hypochlorite. It saves cost, and it is nice to have your product as fresh as possible. Instead of having it transported, we generate it right on site. Okay, let's take a look. Okay, so now we'll start with the on-site hypochlorite generator, which is a really cool feature to have. What we do is we add a salt, system salt, to the container, which brings in fresh water from the intake, from our wells, comes along, mixes with the salt to create a brine. Once the brine goes through the process, it will come out as sodium hypochlorite. This is the sodium hypochlorite generator system, and it transforms the salt brine into a sodium hypochlorite using an electrolysis process through the electrolysis plates. They are actually called rectifier plates. The water comes in and through a chemical change gets transformed into the sodium hypochlorite. And there's a lot of little specifics, you know, your pHs, your softness of your water. There's a lot of time and effort that goes into making sure that the product that we're going to create is a high quality disinfectant. And so when it comes through and gets generated, we fill our 2 holding tanks, which are right here, which gives us the ability to have about 4 days under heavy usage of backup hypochlorite, which never has a chance to break down from age. It's in a controlled temperature environment. We make sure that everything in here is to the right specifications of the system. Okay, now once we've generated the hypochlorite, it stays in the holding tanks until it's ready to go into the clear wells, into distribution. We have to maintain a 20-minute contact time with our sodium hypochlorite with the water. It must contact for approximately 20 minutes to get the best disinfection. We achieve that through the peristaltic pumps on the floor here, which is set preset to the dosage requirements that I've programmed into the pumps. Okay, once the pumps transfer the hypochlorite into the injection point, which I showed you earlier on the UV reactor, then the water that has been UV sterilized and disinfected with the sodium hypochlorite then goes into our clear well. And let's take a look at our clear wells. Okay, now these are our clear wells. We have them under cover so no debris or anything can access our clear wells. And this is the finished product that goes to distribution that feeds our 1 million gallon reservoir, which is our main distribution reservoir for the community. the water that's in the clear well, after it is treated, sterilized and disinfected, it travels through a series of baffles underneath the floor. This is all a big clear well in the treatment facility here. And as the water passes over, any sediment that is suspended solids or anything that is in the water settles out over the baffles. The water level rises over the baffles and comes until we finally have our finished product. And this is the last stage before it goes through our 125 horse pumps that we send the water up to the 1,000,000-gallon reservoir. And we'll take a look at those next. Okay, and here are our lift pumps. These are 125 horse lift pumps which send the water when the reservoir hits 90%, our 1,000,000-gallon reservoir, when it hits 90%, it calls for water. We have to maintain a 70% level at all times in our reservoirs for fire protection. So at 90%, it will call the plant asking for some water. When everything, the sequence that we have went through, when it is confirmed that the quality of the water is good, the pumps start and they lift the water to the 1,000,000-gallon reservoir at about 180 psi, which the pressure from the million to the plant is about 170 psi. So we have to go 5 pounds per square inch higher than that number so we can push against the head pressure of the reservoir. Okay. After the pumps engage, it sends the water along through the piping and then off to distribution. Okay. I appreciate the opportunity to be able to break down our process a little bit to you. You know, it's nice to see how the water comes right from our wells right to your tap. And to have a safe, potable drinking source is priceless in our world today. So thank you very much for your time, and we will keep you updated on our next phases of construction. Thank you.